Okay, hi. In this video, we will talk about a RAG system, a simple RAG system which has fewer bare minimum component to build any RAG system. This RAG system is not, of course, a production ready RAG system. This is just a first step. If you have data and you want to build in something in generative AI and you want to apply RAG functionality, so this is just a first step. So this is a simple RAG. Here is the code through, and yeah, in this video I will only talk about the code structure and the what I have built, not the theoretical part. I will discuss in detail in this video. I'm planning to make another video, detailed video on RAG, in which I will talk about the whole architecture, simple RAG system, and how can we improve that RAG system to make advanced RAG system and actual production ready systems. So let's get into it. Yeah, so I choose acupuncture domain to build a RAG system. RAG is stand for retrieval augmented generation. There are three uh, words: retrieval, augmented, and generation. Retrieval is uh, you have stored your data set and converted into embeddings, and that embeddings is stored into vector database. That vector database will compare with user's query and get the similar context. That's the retrieval part. Augmented part is that gathered context will be uh, supplied to the LLM along with the prompt. Means augmented part of retrieval document plus prompt, which is user query, with some prompt template like system prompt and means more robust prompt. So you got the point. So that's the augmented part, and generation part is happen via LLM, a foundational models. So yeah, I've used LangChain, and so LangChain is a framework to build a simple RAG system. You can go through the documentation. I will show you. So yeah, from LangChain community, first I import PyPDF loader. PyPDF loader is a module in LangChain community dot document dot loader framework. PyPDF loader which take PDF and can read the content inside PDF. I have just imported it and I have want to use this module. Why? Because I have not only single PDF, I have bunch of PDFs. I have 3 PDFs, right? Why this PDF? Because LLM foundational model, if I go and write anything about acupuncture, I will get the answer. But that answer about acupuncture, the ChatGPT, Gemini, or Claude give me will be more generic. It's not a patient specific or more research specific. What I have did is why we have used RAG is to give more context to the LLM. Like we tell LLM that you need to give answer based on these documents only. If you don't know the answer, don't hallucinate, just say I don't know. Okay, so that's why I'm using these 3 PDFs which I got from my professor. So yeah, PyPDF loader. Similar another module is PyPDF directory loader. Directory loader is it loads the whole directory and it loads the whole file inside this particular directory. Recursive characters text splitter is for chunking technique. This FAISS is a Facebook AI similarity search, which is a vector store database. Okay, so vector store database. If you don't know any of this term, don't worry, just stay with me, you will get the point. Chat prompt template, which is a prompt template. Hugging face embeddings, which is a embedding model. Chat grok is a LLM runnable pass through. system, operating system, which is a Python module, and to get the environment variable .env. Okay, so you need to get Grok API or OpenAI API or Cloud API, anything, or Olama API. I suggest to go for open source model only. So use Grok API. I have used only Grok API. You need to store your API right here. I haven't. Right, I have stored in Streamlit. I'll tell you why. But if you want to use only for your experimental purpose in notebook only, Jupyter notebook only, then you can you can create environment variable and use the Grok API or any other LLM API. Okay, so this is a part I've commented out because I don't want to load a single PDF. So I will move to the next part of function, which is a process multiple PDF. It takes argument as a directory path, which is this path over here. It will load all the PDF inside this folder, all the pages with this function, and then recursive character text splitter, which make chunking. Chunking means uh, we provide LLM, we store data in vector store DB with chunk size. Like we split data into small chunk. We are not storing the whole book inside vector store DB. We are partition the whole book with a different small amount of chunk size. Like here chunk size I have declared as 1000 and chunk overlap is 200. Means there is one sentence that end with some word, and the another chunk will be start with last two word of the previous statement. Okay, that's the chunk overlap, which is the most important factor or a deciding factor of accuracy of RAG system. And then we return the whole pages document. Then we create a vector store. Then we create a vector store embeddings with a Hugging Face transformer, and we store it into this vector Facebook AI similarity search, which is vector database. And then at last we are chaining the system, the vector store and RAG and the LLM. Okay, so this is the template. Use this acupuncture treatment context as context, question as question, that will provide an answer in professional medical term. Prompt is chat prompt template. Chat prompt template is some kind of template which enhance the prompt. Okay, so LLM will not get this exact prompt. This prompt will enhance via chat prompt template. I'm sorry. And then LLM is Chat Grok Llama 370 billion parameter model, and return context retrieval runnable pass-through with is pass-through with this information, then prompt and LLM. Then we run the file. After running, you will get this answer. Alrighty. So I will make a Streamlit app with same functionality. Streamlit, I use Streamlit time line chain, same vector database, chat prompt, the same function I have declared over here. I have declared in app.py file. You can get this GitHub link in the description. Okay, so this is a Streamlit code. Okay, so I will run the code and show you. So let me activate the virtual environment, and I will run via Streamlit run app.py. Streamlit run app.py, and hit enter. And this application is look something like this. I have prompt that I have a back pain. How can I treat with acupuncture? Now I will enter, and this is analyzing clinical guidelines, and it is hitting the Grok API via Grok API, and then LLM will generate the answer. It will take few seconds because yeah, because of the interface. It depends on what interface, what inference you are using actually. Yes, I'm using Grok, which is a little slow. If you use OpenAI, it will generate at different speed. Okay, so this is the answer, and yeah, this is the answer. And one more thing, yeah, and one more thing. If you clone this repository, you need to uh, make this dot streamlit folder, and inside this dot streamlit format folder, you have to make one file name with secrets.toml, and inside this file you have to add your Grok API key this with this format. Okay, of course this API key will not be valid. I will delete this API key, so don't copy my API key because otherwise you will get error. So okay, so once you clone the repo, you first step, you go and create this dot streamlit folder, and inside this folder create a file secrets.toml, and you're good to go. Yes, I'll provide the GitHub link in the description. And yeah, so this is all about today's video, and I will see you in the next one, in which I will give you a more explanation about RAG system. What is RAG, and what is the architecture of simple RAG, how can we improve this RAG system and to the production level RAG system. Yeah, thank you. Bye bye.